Hey guys, and welcome to another tutorial. Today I'll be going over Matplotlib, which is a plotting library for Python. You can plot graphs, 2 dimensions and 3 dimensions. I will show 3 dimensions in this video near the end. It's good for allowing you to visualize data and just graphing in general. Like you would be doing in your algebra class, you can graph with Python. So the way to get this module is first you actually have to pip install it. So you want to go to your directory, and however you normally install modules, just say pip install matplotlib. And yet again, if that doesn't that's interesting. If that doesn't work for you, then run this command, python-m, and then pip install matplotlib. And it should begin to actually download for you unless you already have it, in which case it'll say requirement already satisfied. So what we use when we're importing, our first import statement will be import matplotlib.pyplot as plt. Now this is the part of the module that actually plots. So we don't actually need to import matplotlib, we just need to import this section. And we normally import it as PLT. You can do whatever you want, but this is just the normal convention. Okay, so first I'm going to go over plotting just lines, and I'll also show you, the kind of Matplotlib interface once you graph. So we're going to start off by creating a list of x values, say 0, 1, 2, 3, 4, and y values 0, 1, 2, 3, 4. And this is pretty important when you're graphing. You put all of your x values in one list and all of your y values in one list. So if we were actually graphing this, like normally, then we would actually end up with something like this. So if we look here, why is that okay. So I'm just doing this for visualization purposes. We're actually plotting these 5 points here, but we put all of the x values in one list, as you can see here, and all of the y values in one list. So do not mix them up. These are the points we're plotting, but we're putting them in separate lists for x and y values. Once you do that, you can say plt.plot x, y. Plt.plot will plot a line for you. And then at the very end of any Matplotlib, script, we have to write plt.show. And this will actually show our graph on the screen. So now if we run this, you'll see something looks like this. And this is the Matplotlib interface. So as you can see here, we have graphed these points 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. And as I told you, we put them all in one list, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. It connected them all for us since we ran plt.plot. You can also move around here. You can click this right here, which will allow you to actually pan around the graph like this. If your graph is big, you can move up, and you'll see the axes change once you do that. And if you want to reset the original view, you press the home button right here. You can also zoom in. So if you want to zoom in, let's say on this section right here, you can actually draw a rectangle, and that rectangle will become your new screen, as you can see here, and you can zoom in all you want. Then let's reset. Then you can configure subplots, do a bunch of stuff here. It's like a calculator, I guess, how you can change the window. You can save your figure if you really love your graph as a PNG file. And as you'll see in the bottom right, whenever I'm going over the graph, it'll show the x and y coordinates of my mouse, as you can see there. And so yeah, this is the basics of Matplotlib. Okay, There's a few other stuff I'm just going to show you how to do here. We can change the color of our line. So let's say we want the color to be blue. We can put in an extra parameter here saying color equals blue. And in which case it'll turn out blue, as you can see here. We can change the width of the line, and that parameter is line width equals. So let's say 5. And as you can see, it's much more thick. The line width is now 5, the width of the line. We can also create a label for this line, and let's just label it line 1. And you won't see anything right now, but you'll see later. Let's actually plot another graph here. Let's do this. Yeah, okay. So just kind of a whack graph. Oh, we forgot to actually plot it. So we can put in multiple lines in the same screen. Just pass in another plt.plot. I'll make this one red so we can differentiate, and I'll label it line 2. And as you can see, we have 2 different lines now. I'm actually going to start this one at 0. Start this one at 0 too, just so it looks a bit better. Okay, there we go. Actually, don't. Alright, that's good enough. Now what we can do is, the purpose for me writing these labels here is to actually create the legend for the graph. So here we go. You can create the legend for your graph. If you don't know what like a legend, the x-axis, y-axis, and the title are, then you should probably learn those first. But here's the legend right here. So the blue, it's indicating here that the blue color is showing line 1 and the red color is showing line 2. And that's what line 1, line 2 are what we named it up here. So we can change that, and it'll change accordingly. We can change the title of our graph. So let's title this greatness. Obviously it is greatness. I'm just going to change that here too. And as you can see, we have the title up here. Now we can also change the title of the x-axis. And actually, wait, I don't remember exactly. Let me see one thing quickly. We actually need to close that. There we go. Let's see. X label, okay. So, let's check right here. And as you can see, it actually labeled the x-axis. We can also label the y-axis. And I'm just doing arbitrary values here. If you were graphing like a real like data set or something, you could obviously change it accordingly. So here we have created a pretty basic graph. We have our lines. We have a legend here indicating which line is which. We have our title, we have our x-axis and our y-axis, and we also know how to manipulate this over here. We can also actually change the style of our plot. The way we do that is we come at the very top and we write plt.style.use, and then in here we have to pass in a string. I'm going to pass in ggplot. They're different styles of plots. They're limited amount. ggplot is one of them. And as you can see, the graph looks different because I used a different style. If you want to see all the styles, you can write style.available, plt.style.available. And here are a bunch of styles. As you can see here, we have classic, dark background, fast, 538, whatever. Just so we can kind of get a bit of variation. I'm just going to randomly select one every single time I graph. Random import choice. So we're just going to do this. So we can kind of look at the different things every time. It's just going to choose a random one. It's not callable. Oh, my bad. So it's just going to choose a random style, and it's going to apply that, and that'll be the style for a graph. So I'm just going to keep that at the top there every time. Another thing we can do is actually create a grid. So if we come down here, we can say plt.grid, and then pass in true. And then you can see we actually have a grid here. So I went over a lot of stuff really quickly. So let's just go over them again. So we have, so at first we can, create our style, and plt.style.available is a list of all the possible styles you can use. And then you run plt.style.use to actually use that style. We create lists of x and y coordinates. And as I told you, you put all of your x coordinates for that line or whatever in one list, and all of the y coordinates in another list. And then when you go to plot it, you pass in the x and y list separately, as you can see here. There are a few other parameters you can pass in. You can pass in a color parameter to change the color of your line. You can pass in a label parameter to change what the name of the line is in your legend. You can also pass in line width to change the thickness of the line. As you can see here, we plotted two different lines. We labeled the x and y axes. We created our legend here, which used our labels up here. And then we also made a grid by running this. And then at the very end, we have to run plt.show so it actually appears on our screen. And the end result is like this. Okay, that was for lines. Now I'll go into other forms of graphs. Okay, now I'm going to go over bar graphs. So in a bar graph, let's just do the beginning stuff here first. Bar graph. We'll label the x-axis as x-axis and the y label as y-axis. We'll create our legend, which we'll fill in soon. And then we'll also put our grid as true. So it doesn't hurt. Although it's not really that necessary for a bar graph. That's fine. Okay, and in here we'll actually make our points. So the way we do bar graphs are, as you know, they come up as value. They are like bars, as it's pretty self-explanatory, and pretty much a different bar starts at a different x value, and it goes up to a certain y value. So when we create our x and y lists, that's what we're actually plotting. So it's best probably to show us by an example. So let's create an x list of 0 to 1, 3, 4, and 6. Let's do that. And let's assign this as 3, 5, 3, and 4. So what this is going to plot, it's going to plot a bar graph. It's going to plot a bar at x coordinate 1 that's 3 coordinates high, one at x coordinate 3 that's 5 coordinates high, one at x coordinate 4 that's 3 coordinates high, one at x coordinate 6 that's 4 coordinates high. And the way we plot this is saying plt.bar x and y, and then we can pass in our other just variables as we want. Okay, and now if we run this, you'll see we have our graph, bar graphs. So, oops, where'd it go? No? Okay, there. So in our bar graph, we have a bar at x coordinate 1, and it goes up 3 coordinates high, and that's what we graph here, 1, 3, that's at x coordinate 1 up to y coordinate 3. We graphed 3, 5, that's at x coordinate 3 up to y coordinate 5. 4, 3, that's at x coordinate 4 up to y coordinate 3. And 6, 4, which is at x coordinate 6 up to y coordinate 4. So those are bar graphs. You can also graph multiple. So let's do what we did before with this, and let's make these one a bit taller. And now if we create the bar again using our new values, we can see, let's graph this one as blue, and we can label this as a different one right there. And if we graph it, you can see we have all of the different graphs. We have the original ones, and then we added new ones here at x coordinate 2 up to y coordinate 7, from x coordinate 5 to y coordinate 9, from x coordinate 7 up to y coordinate 6. And as you can see, as we labeled the new one candy bar, and that's what it popped up in the legend. Alright, the last type of two-dimensional graph I'll go over in this tutorial will be the scatter plot. This will just plot random points, and so yeah, it's just gonna plot individual points, not a line, not a bar graph, nothing like that. So let's just take this out. Scatter plot. And actually, I'll use my current ones, but I'll just change it to scatter and scatter, because plt.scatter will create a scatter plot. If we graph those, you'll see it actually graphs the individual points, as you can see here. So we have the point 1, 3, we have the point 3, 5. I'm looking at the first ones here. That's the ones that appear in green, because that's what I labeled them. We have 4, 3. We have 6, 4. And for the blue ones, we have 2, 7, as I made here, 5, 9, as I put here, and 7, 6, as I put there. So this one will just graph individual points, whereas plt.plot graphs a line, and plt.bar creates a bar graph. So those are the basics for two-dimensional graphs. Now I'm going to go over three-dimensional graphs, just very basic. I'm only going to go over lines and scatter plots in 3 dimensions, because making, surfaced graphs and contour plots and things like that, those usually use some matrix knowledge, which not everyone knows. So I'm not going to go over those right today. I'm going to just go over scatter plots and line plots with 3D Matplotlib. Alright, so to plot in 3D, we actually need to add an extra import. This will be from MPL Toolkits, import Toolkits 3D, right? Let's see if that's correct. I actually don't think it is. Yeah, okay. So let's see, what was it again? Mplot3D. .mplot3D, not 32. Import axis 3D. So this is what we're going to use to actually plot in 3D. Now, if we want to create our three-dimensional graph, we have to run these 2 lines. So, and we almost always run these 2 lines. Figure equals plt.figure. And then we say ax equals figure.add subplot 111 projection equals 3D. So hopefully that all works out, and there we go. So this will create our 3D graph for us. As you can see, projection equals 3D. And from here, we can begin to graph. So I'm going to start off with some basic stuff. I'm going to set the title, as I said before, 3D scatter plot. That's what I'll graph first, I guess. We can set the X label to be X-axis, and we are going to continue that all the way down for Y and Z. Alright, I hope it is set. Yeah, there we go. Okay, so now if we actually show this, I don't know if it's going to show right now. Show. Okay, there we go. So this is our 3D plot, as you can see. We have the x-axis, the y-axis, the z-axis, and this is the 3D scatter plot. So z is obviously the height, and then x and w are length and width, respectively. And we can move this one around too. We can, pan. We can zoom in. Oh, actually, I guess we can't zoom in. Just gonna keep on panning. We can configure subplots and things like that. Alright, so we're gonna start off by doing something very similar to how we would, scatter in two-dimensional graphs. We're gonna create a list of x, y, and z, which will refer to the corresponding coordinates in the individual points, and then we're just gonna plot x, y, and z. So x, we can say 0, 1, 2, 3, 4. We'll say this is 1, 2, 3, 4, 5, and we'll vary this one a bit. So we'll say 7, 3, 4, 1, 2. Let's change the color to blue. Let's label it 3D line. And let's just say plt.legend at the end here. And as you can see, we have this weird line. It looks really dumb here, but if you move it around, you can actually see the full line. It's just that at that angle, it appears to be straight. But in reality, it is varied, as you can see here. And we can obviously change that. So this looks a bit off. So let's just do 2, 4, 5, 7. Okay, so now it's gonna go, it looks straight, but once you move it, you'll actually see it. So we have the X and Y and the Z here, and that's just our basic line plot. It can look a bit weird with, the axes changing and everything, but the actual line stays the same. The only thing that changes are the axes on how it looks. And yet again, you can save this as a PNG file if you wish. As you can see, we also have our label up here. I actually haven't tested this out, but maybe we can do the style thing. Let's see. Style.use choice plt.style.available. Let's see if that works. Alright, I'm not sure if that's like a style or something, or whether. Let's just try a basic one. Dark background. And if it works, then well, it works. Let's see. Style.available. Okay, well, let me check. Dark background, okay. Let's see if the styles actually work. Oh, okay, I guess they do. In the background, but not up here. Alright, whatever. That's fine. So, as you can see, we have our basic plot. Let's see if grid works either. I haven't actually tested that, even though I think the grid is already provided for us anyway. So it's not much of a thing to worry about. Yeah, but here we go. This would be a basic 3D plot. That's just not our scatter. I was thinking this is a scatter plot. My bad. This is actually the line plot. As you can see, that was obviously a line because we use ax.plot. And if we want to do a scatter plot, then well, it's the same thing except ax.scatter. And in which case, we'll see we have the individual points graphed on the 3D plot, as you can see. So that was so I think that's going to wrap it up for this tutorial. That was the Matplotlib 2-dimensional and 3-dimensional tutorial. I hope you benefited from this video. And yeah.